Lesson 25, Basic Rules of Probability. The probability that a particular event E occurs is measured by the proportion of the time that event can occur, where each of the fundamental units used to count the total number of possible outcomes are equally likely. So here, this formula, P of E is equal to F of E over N, is our basic rule of calculating probabilities using the relative frequency or proportion approach. This relative frequency or proportion approach to calculating probability relies on counting the number of ways the event can occur out of the total number of possible outcomes. Thus, F of E, the frequency, is the count. The lowest the frequency can be is 0, and the highest the frequency or count can be is N, the total. So F of E, the frequency, which counts the number of ways the event can occur, can be as low as 0, or 1, 2, and so on and so forth, to as high as N. Thus, when calculating the probability of the event occurring, we just divide this frequency by N, the total number of possible outcomes, giving us the probability of E is equal to the frequency of E divided by N, the total number of possible outcomes. Thus, the lowest the probability can ever be is 0 out of N, and the highest the probability can ever be is N out of N, or anywhere in between. 0 divided by the total N always equals 0, and N divided by N, the total divided by the total, always equals 1. So the lowest the probability can ever be is 0, and the highest the probability can ever be is 1, or any other value, fraction or decimal, in between 0 or 1. The probability that a particular event E occurs can only equal values on the interval from 0, or 0%, to 1, or 100%. This result is denoted mathematically by 0 less than or equal to P of E less than or equal to 1. This is indicating that P of E, the probability that any particular event occurs, falls in between the values of 0 to 1, including a low of 0 up to a high of 1. This can be visualized on a number line this way, where 0 is the lowest the probability can reach, and 1 is the highest the probability can reach. Whenever the probability of an event equals 0, that event will never happen. So a probability of E equals 0 indicates that the event will never occur. When the probability of an event equals 1, that indicates that the event will always happen. So an event will always happen when the probability of the event equals 1. All other probabilities fall somewhere between this range from 0, meaning never happens, to 1, which means always happens. So probabilities in between just indicate that sometimes the event can occur and sometimes it does not. Reading this scale in this manner is how we interpret probabilities. That is, an event is considered to be likely to occur when the probability of that event occurring is close to 1. So the closer that probability is to 1, the closer that event is to always happening. So an event is very likely to occur when that probability is very close to 1. An event is very unlikely to occur when the probability of that event occurring is close to 0. The closer that probability is to 0 means the closer that event is to never happening. So the smaller the probability, the less likely the event is to occur. The higher the probability, the more likely the event is to occur. An event is considered to be unusual when the probability of that event occurring is 5% or less. That is, the P of E is less than or equal to 0.05 decimal. So unusual means it doesn't occur very often. We will define an event as not occurring very often or unusual at 5% or less. So whenever that probability is small, 5% or less, we consider that event to be unusual. In previous lessons, we defined unusual in another way. So in statistics, unusual results are identified either by their standard score, that is, its standard score being 2 or more standard deviations away from the mean is considered unusual, or by their probability. the probability of an event occurring which is 5% or less is considered unusual. Overall, both approaches produce equivalent determinations. So if we're dealing with probabilities, we can use the unusual rule as 5% or less. But if we're dealing with means and standard deviations, calculating the standard score and looking at it being 2 or more standard deviations away from that mean is a way to identify unusual outcomes. Since any event will either occur or not occur, it will always be the case that the probability of E plus the probability of not E equals 1. That is, it's guaranteed to always happen that something either happens or doesn't happen. We could take advantage of this mathematical equation by solving for the probability of an event does not occur by subtracting the probability that it does occur. And what we do to one side, we do to the other side of the equation to keep things equal. And when the probability of E subtracts the probability of E, just leaves us the probability of the event not E occurring is equal to 1 minus the probability of event E occurring. So we could calculate the probability that an event does not occur by taking 1, the total probability, minus the probability it does occur. We can also solve this equation for the probability that event E does occur by subtracting the probability that event E does not occur. And what we do to one side, we do to the other side of the equation. And when we add the probability of not E and subtract the probability of not E, they zero out, and we're just left with the probability of event E occurring is equal to 1 minus the probability the event does not occur. So we could find the probabilities directly by counting, or we could calculate these probabilities indirectly by doing the 1 minus the opposite probability. Thus, the probability that an event does not occur can be calculated by going 1 minus the probability that the event does occur, and the probability that an event does occur can be calculated by going 1 minus the probability the event does not occur. The probability that either event E occurs or F occurs could be determined by the following rule. Since the result could be either event E or event F, all occurrences of event E and event F are included in the probability, provided that no single outcome is counted more than once. So this is reflected in the rule by saying that the probability that either event E or F occurs can be found by taking the probability of E occurring, adding it to the probability of F occurring, and subtracting out the probability that both E and F occur. The probability that event E occurs, given information that event F has already occurred, could be determined by the following rule. The given information redefines the total number of possible outcomes. So the probability that event E occurs, given F has already occurred, is calculated based off of the total of event F. So when it's given F, the total is the probability of F. And then the frequency is counted based on just the E's that occur in the given information. So the probability that E occurs given F occurs can be calculated with this rule by taking the probability that both E and F occur and dividing it by the given probability of F. If the given information regarding the occurrence of event F has no effect on the probability of event E occurring, that is, the probability of E given F is equal to the probability of E, then event E and F are considered to be independent of one another. Events that are independent are unrelated to one another. If the given information regarding the occurrence of event F has an effect on the probability of event E occurring, that is, the probability of E given F does not equal the probability of E, then events E and F are considered to be not independent of one another. Events that are not independent are somehow related to one another. The probability that both event E occurs and event F occurs could be determined by solving the given probability rule for the probability of E and F. To do this, we will do the inverse of dividing by the probability of F by multiplying by the probability of F. And what we do to one side of the equation, we do to the other to keep everything equal. Here, multiplying by the probability of f and dividing by the probability of f gives us 1. So we're just left with the probability of E and F occurring is equal to the probability of F times the probability of E given F. Rewriting this rule in this form, we find that the probability that both E and F occur together is equal to the probability of F times the probability of E given F. In order for both events E and F to occur together, first event F must occur, and then, given that event F has occurred first, event E must occur second. Thus, to get the AND probability, we end up multiplying these particular probabilities together. So here are some basic rules of probability. Starting with our relative frequency or proportion approach, where we can find probabilities by counting the number of ways that event can occur and dividing it by the total number of possible outcomes. This approach to calculating probabilities can be done for most probability problems. But sometimes the probability problems involve certain key phrases, such as not. So you can calculate the probability that an event does not occur by using the relative frequency approach and counting the number of ways the event does not happen and divide by the total. This is the direct approach. Or you can find this probability indirectly by taking the total minus the opposite probability. So you could find the probability that an event does not occur by going 1 minus the probability it does occur. Another key word of joining events and probability is or. So if you want to find the probability that either one event E occurs or another event F occurs, you could find that probability by counting the number of ways both E or F can occur and divide by the total. Or we can use the basic rule of the probability of E or F, which says that it's the probability of E plus the probability of F, subtract the probability of E and F. That is, in order for the events one or the other to occur, we just count any one or the other. Thus, we add the probability of E and the probability of F. But we don't want to count any event more than once. So that's where the subtract the probability of both E and F occur happens in the rule so that we don't count anything twice. Another key word is and. If we want to find the probability that both event E occurs and event F occurs, we could count the number of ways that both of those happen together and divide by the total, or we could follow this basic rule for and. The probability that both event E and F occur is calculated by taking the probability of event F occurring first times the probability of event E happens second, given that event F has happened first. So to find the and probability, we multiply these corresponding probabilities. Another key word, given. To find the probability that event E occurs given F has occurred, the given basic rule of probability is essentially the same as the relative frequency or proportion approach. The difference is the given information just redefines the total. So to find the probability that E occurs given F has occurred, we calculate the probability based on just the given information, or in this case, F. So the probability of F becomes our new total. And then we count the number of ways the event E can happen out of that new total. So we take the probability that both E and F occur and divide it by the probability of just F occurring to find the probability that E occurs given F. So these basic rules of probability can be used individually or together to solve probability problems. You could either find it by the counting approach, or you can find it by using the basic rules based off the keywords not, or, and, given. Where not means we're going to subtract from the total to get the opposite probability, or means we add probabilities, making sure we don't count anything twice, and means we multiply specific probabilities, and given means we calculate that probability based on the given new information or redefined total.